I guess we can begin then. So hi everyone, welcome to the Data Science Club's Professor Panel. We want to thank our guests, Professor Buyske, Professor Petre, and Professor Mardekian for joining us. And also welcome to everyone that was able to make it.
Hi, everyone. We're really excited to get into our discussion on everything about data. But real quick, before we do, we want to get into a little bit of general housekeeping. So please know, as you just saw, this meeting is being recorded with the consent of the professors. And that being said, I believe everyone is force muted, but we still could ask everyone in our audience to stay muted. You're more than welcome to turn on your cameras if you feel comfortable. There will be time at the end of the event for questions from the audience. Also, we ask that all students in the audience for the Data Science Club take a second to fill out the Google form in the chat. That's for attendance. And as more people join in, the chat will be updated with the link.
We'll start with the introduction, starting with the e-board. I know you've heard us talk a million times, so we're going to keep it very short and simple. So yep. Mike, you can start.
Yeah, so hi, I'm Michael. I'm a junior and I am the president of the club.
I'm Michelle. I'm also a junior and I am vice president of the club.
Hi, I'm Anastasia. I'm a freshman and I'm the treasurer of the club. Our secretary Muskan wasn't able to come today, but she's a senior. And now we'll start to introduce our guests because, of course, they're the most important people that came today. And we're going to be starting with Professor Buyske. It's very nice to see you today.
Yeah, so I'm Steve Buyske. I'm in the statistics department. I've pretty much been in academics my whole life. I started in mathematics and switched to statistics. Mostly I work with large like consortium of scientists, multiple institutions, mostly in genetics. And I'm also, relevant to this, I'm the undergraduate co-director in statistics and the undergraduate co-director in data science.
Thank you so much for joining us today. We'll continue with Professor Mardekian.
Yes, hi. Hi, everyone. My name is Dr.Mardekian, and I joined Rutgers in 2020 after retiring from Pfizer after a 40-year career in the pharmaceutical industry. And I actually graduated from Rutgers with my master's, so I'm a student, and I've been teaching as a part-time lecturer for many years at Rutgers. So I came to Rutgers because I enjoyed teaching and the contact with students, and that was in 2020, and then the pandemic happened, and I wound up teaching from my home remotely. So it's nice to see some fresh faces.
Thank you. It's very great to have you here. And we'll end with Professor Petre.
Hi, everybody. It's so nice to be here, and thank you so much for inviting me. I am an assistant professor in the Department of Journalism and Media Studies in the School of Communication and Information. So my research orientation and how it concerns data science is a bit different. I study what I like to call the social life of digital data analytics and algorithms. So I sort of study the ways in which forms of data, particularly in the workplace, that evaluate the performance of workers actually kind of are designed for particular workplaces and also are kind of taken up in the environments where they're implemented and how people either accept them or push against them. So I do qualitative research generally on quantitative forms of data.
And again, so thank you all for coming. And I think we can start with our questions about data science as a degree program. So just to begin, as many of us know, Rutgers last year created the undergraduate certificate program and a bit later the minor. And now they're in the in the slow process of making the major. So I'm assuming that everyone that came to the meeting is at the very least somewhat interested in data science, but given despite that, Rutgers does have a lot of majors that do have a lot of aspects of data science, such as computer science, IT, and statistics. And so, in your opinions, why do you think that the curriculum of the data science degree program was a necessary addition for Rutgers? Any of you can speak up, I guess.
I'll take a shot at it. So the so one of the things about data science as a field is it's a newish field, and it's not particularly well defined either, by sort of people now or over time, and so it changes, and the people that go in, the people who have jobs that call themselves data scientists, they have lots and lots of different backgrounds. And so I was thinking of a couple sort of particular data scientists, and one was a math and physics major. I think one was she was a math major, and the other she was a journalism major. And so you can sort of come from all sorts of ways, but we thought it would be sort of helpful at Rutgers to have something that actually gives a focus to it. So, for instance, there's a lot of computer work in data science, but if you're a CS major who's really interested in data science, you're going to find yourself taking things like operating systems and stuff like that, which are maybe not like what you really are interested in. And so having programs that are focused in data science, it's going to help with getting jobs and things, but also enables students to spend their academic time sort of more focused on the area that they're interested in.
And this is Jack. Basically, as I saw it from Pfizer perspective, we were faced with all sorts of data that we weren't faced with before. And so you saw the big data. All of a sudden, people were talking about big data. We were basically a pharmaceutical industry company, and we were dealing with clinical trials. So we had nobody, we had IT, and they were more computer oriented. So we didn't have anybody that could, basically address or analyze these data. There were statisticians who could, but their job was in clinical trials. So it kind of grew, I think, because of the demand out there, right? So it's good to see Rutgers recognize that it is a need for society. I mean, the more quantitative you are, I think in today's world, the more likely you are to be successfully employed. So I just think it was because of the growth of data and the advantages and the new software that was available to analyze that data.
I think just one thing I would add to what both of you have said that I think is really cool about the emerging kind of data science programs at Rutgers is how interdisciplinary they are. So, really not just being housed in one department and being spread across the departments that you would expect, like statistics or computer science, but then also, for instance, having courses in the School of Communication and Information, having potentially, down the line with the major courses from departments that we might typically associate with being the humanities, kind of getting in on this too. And so I think there's something really potentially really innovative, I think, about having a truly interdisciplinary data science program that takes advantage of the vast breadth of Rutgers as a university. And then another thing that I think kind of piggybacks on something that Steve was saying is that my sense of data science as a field is that it is emerging, and it's also in this moment where it's professionalizing. So it's sort of figuring out its identity as a profession. And we talk about this in the course that I'm teaching this semester, Data in Context. There's all this talk now of well, maybe data science should have a Hippocratic oath the way that doctors have a Hippocratic oath, right? There's all these conversations that are really generative and interesting and important that are happening right now about what kind of field is data science going to be? What kind of profession is it going to be? And so I think there's an advantage to having a program that is devoted to this emerging profession and helping to even shape it. And being kind of set apart from the existing departments that we have at Rutgers.
That's a really interesting point. How data science is kind of in all of these different fields, so much so that it as its own field is growing more relevant. And I know from experience, like us at the Data Science Club, we like to promote the degree program as one that complements any major degree program that any of the students interested in data science are currently in. And so you all just like spoke, Professor Petre, you said you work with data science that's rooted in journalism and media studies. Professor Buyske, you mentioned your statistics background and your mathematical background. Professor Mardekian, you mentioned the pharmaceutical background with Pfizer. So in the same way that data science is becoming relevant and becoming its own field because of its relevancy in other fields, how has data science changed the curriculums of your respective departments during your time as educators?
I'll answer it simply, and then before I was teaching, using SAS. Okay, that was the language of the farmers. So I have a simple answer to that. All of a sudden, I started teaching R because R is so popular out there as a language. Right, I let the other computer science people teach Python, but my, R is free software. And so basically it changed the curriculum that all of a sudden I had a software package that was available to all students, and it developed in all students a skill that was certainly marketable when they graduated from Rutgers.
I would say in terms of the Department of Journalism and Media Studies, I think there are ways in which I would like to see us, and I think we all would like to push further into this area and have the emergence of data science start to change our curriculum a little bit more than it has already. So in terms of where I see that going or hope it will go in the next couple of years, I see us building out our course offerings in analytics. So analytics has become a huge aspect of the way that journalists do their jobs, looking at data that tells them about what audiences are doing in terms of interacting with news content and what they're responding to, and even tools that predict algorithmically, what will do well and all the ethical issues that raises and everything. But just teaching journalism students to become conversant with data analytics with regard to journalism content. And then related to that, we've seen an explosion in what is typically called data journalism. So using data science techniques to actually do reporting in a newsroom and uncover investigative stories and things like that maybe wouldn't be able to be unearthed via more traditional reporting means like interviews. So I would like to see us sort of pushing our curriculum a little bit more in that direction. I think that's where I see us going. And I teach a course in the department now that's called Media and Data, where we look at the way that data and algorithms are kind of infiltrating a lot of media industries. So not just journalism, but also film production and music production and even book publishing, right? So that's sort of how we start to see these topics coming into my department.
One thing I'll add is just even in teaching a straight up statistics course is that both I think what I want to do and what students want to see is I much more want to use bring in interesting data and sort of current data. 25 years ago, I felt I was really innovative because I used data on the Titanic to sort of illustrate things. Now that's pretty much like old hat, and it's it's kind of boring, I think, if I do that. But for example, in my course last semester, the Bayesian course, we looked at the racial bias in jury selection, and that's just to be able to sort of bring in the data and do the analysis on something that was involved in Supreme Court cases and a really good data journalism project. And I should say, not only was that a really good data journalism project, but the people who did it sort of made all this stuff available so that I could use it for my own purposes in class. That was something that was very difficult to get data like that 25 years ago, and now it's pretty straightforward to do so.
And I'll just add also that what you're seeing as data science matures and these methods mature, I think Rutgers is starting to hire the experts in the field, right? I see more job descriptions or more positions, teaching positions available for people who are expert in this field. So they're not going to Google necessarily. They're going to the academic world.
Actually, this topic lines up perfectly with our next question because it was going to be talking about the graduate degrees that are being offered. So what do you think, like to reiterate, what do you think are the benefits of pursuing a graduate degree, and what types of graduate degrees would be the most helpful for people who want to enter the data science field?
I'll take the first one again, just because I see from a very practical sense. I could tell you at Pfizer, the project in statistics, the project leads are PhD statisticians. And so, but in data science, I think a master's degree is still, it's new enough field that basically a master's degree is seen as a terminal degree. Right. And so I think that's an advantage, right, as the in its early stages of the career. So as time goes by, I think you're going to see more and more demand for a PhD in data science as a prerequisite for the position. But there are still plenty of jobs out there for bachelor's level and master's level. I hear from my students all the time about getting jobs in something associated with data science.
I looked up some numbers, and for positions that are like data science is part of the title. A bit more than half of the people have master's degrees, only maybe like 10% have bachelor's, and the rest PhDs. But if you include like data analyst or analytics or something, then I think it's a much higher proportion, both of master's and of bachelor's. There is actually, Jack and I were talking to a person who's at Amazon, who used to be a professor at the statistics department. And he mentioned that there is a difference in that, like in computer science, a place like Amazon and many of those sorts of places routinely hire people with bachelor's degrees. But for a job that's if in the data science groups, the sort of the routine thing is to hire people with masters. So there are exceptions across the board, but that's sort of like the thing that happens. And their masters in data science is sort of the most typical thing, though it can be other things as well.
Let's now move on to the questions in data science as a personal skill.
Yeah, so a lot of the people in the audience here are obviously interested in data science, as they did come to the meeting, but I'm sure a lot of people don't know too much about the field yet, or they might just be CS majors, stats majors, something along those lines. So what would you say to people that are on the fence about the field? and what influenced you to see the value of data science as a personal skill?
So I think it's, again, basically you go to college because you want to gain skills that'll lead to a successful career, and a successful career nowadays means, I think, industry, right? There's so many opportunities out there. So I think as a skill, the more quantitative you are, along with the other soft skills, but basically the quantitative skills will attract recruiters to you for positions.
Yeah, I would just second. I mean, I think that it's very buzzy. Like I think that it's very, it's something where there are a lot of jobs right now. There's a lot of demand for people who have these skills and can demonstrate that. And I think, it's an area that so many different fields are trying to build out capacity in. So you don't kind of have to pigeonhole yourself. Like if you're interested in, virtually any professional field, there's probably some avenue by which you can use data science skills to enter into that field. Like it's just because it's something that is, such a hot area right now. So that's one obvious source of value.
And I'll add that it's actually really fun. I work with a bunch of people and I learn all sorts of, there's a lot, I don't learn things systematically, but I learn all these little things. Like I work with some people who are asphalt engineers. They help tell the state what roads need to be repaved. So I know, that crack outside my house, that's no problem. That's a longitudinal, whatever crack. So I've learned a lot of, I never took a course in genetics. I know a huge amount of genetics now from working with geneticists. And it's just sort of like whatever kind of floats by, or basically out of teaching, I started using examples of the popularity of baby names. And so now, I happen to know that my three sisters and I all our names were all like among the most like Stephen was most popular right around the time that I was born. And the same is true for all of my sisters' names. And I don't have no idea how my parents did that. And so, you just sort of like find out these things. It's more than fun to take data, which is not, it's not entirely clear what's going on, and to be able to build a model that gives you real insight. And and then sometimes it turns out that insight is misleading. Sometimes it's useful. Sometimes the data is not so good. And so it's really fun to see that. It's a lot of like figuring out puzzles and tracing them through and trying to check whether you're right. And even something like data cleaning is this sort of weirdly satisfying thing to do, to sort of take this horrible data and turn it into nice data.
Thank you. That's really.
Yeah,
sorry, go ahead.
Just one last. So I had a student that majored in human resources. And, that you would say is so far away from being quantitative, but I was surprised that she was picking up data science courses, statistics courses, computer courses. And I could see that person being hired in a company as a human resources individual, but building a system for that group that predicts basically job performance on candidates who are applying for jobs. So as Steve indicated, it's just an exciting field, and everything is open. There are no closed doors. Right.
You all mentioned, the various fields and industries and how data science is coming up and just becoming more relevant. And I think we can also see it in our daily lives, like how social media apps are, implementing data science techniques and data science concepts in order to mine all of this data from its users and keep us on the app and keep us interested and keep themselves relevant. And then also, we have now fridges, like refrigerators with artificial intelligence that can use data science methodology in order to tell me that I need to go buy milk and I'm running low on eggs and I need more chicken. I don't have any more chicken. So like we're seeing data science in literally every single industry. So in, separate from your own careers, how have you been able to apply or at least recognize data science in industries you didn't expect to see it in?
So I sort of want to point to Caitlin here because I think journalism has been one of the biggest things about how data journalism has become such a big sort of presence. And, like I think it was Monday this week, the most of Above the Fold in the New York Times was a series of plots, data from Our World and Data. And the New York Times has interactive things and lots of websites have such things like that. It's really been quite striking, not something I really would have predicted 20 years ago.
Yeah, I agree with that. And also, some of the stuff that's going on in journalism that's really geared towards nudging the behavior of readers in particular ways, I think is really fascinating. Like, how can we, what is the pathway, like trying to model the pathway by which someone goes from being a casual reader to reading their 5 free articles to then getting them through that funnel to subscribe. These are the kinds of things that news organizations are hiring data scientists to figure this out for them. So it's been really fascinating to watch that, both as a news junkie myself, and then also someone who also studies the journalism industry. And I think I do notice it in my own life. I don't have a fancy fridge that tells me when I need more celery or whatever. Nor do I have like a water bottle that tells me that I, need to hydrate more. But I do notice, just the way that these sort of behavioral nudges on apps that we use all the time affect me, even as I'm very well versed in how they're supposed to work. Like I'm doing this app Duolingo right now to try to learn Spanish, like just because I've always wanted to learn. And so it's like it's very gamified. It's little games, and then you have a streak, and every night they tell me like you're in danger of losing your streak, and I'm like, oh my gosh, I have to maintain my streak. Like I've got to do it, even if I'm so tired and falling asleep. And so I think that you see kind of the outcome of, all of that is, I'm assuming, based on, analysis of what kinds of behavioral interventions are the most effective and lead to the desired output. So, I notice those working on me all the time.
And I would be hard pressed to try to figure out a field that hasn't been touched by this revolution. My daughter is a pathologist, and I'm trying to get her to convince her that she should go for a master's in data science, because in her field, the whole concept of reading tissue samples and so on, that's all impacted and being improved by these analytical models that are being established.
As you mentioned, like data science and the release of more data is like a revolution. And as years go by, more and more data is taken yearly and released publicly yearly. And I think we've all seen like news fails when they post some data graph that is completely wrong, and when news sources post data and then people interpret it completely wrong. And in general, like the general public right now has a very big lack of data literacy. So how do you think we as data science students can like tackle each other's inexperience in data science? And what do you think we can do to like raise awareness for institutions to bring like to make sure that institutions understand that it's very important for everyone to understand data and to be able to analyze data?
That's a tough one.
Yeah, it's such a great question. I think our silence, now my silence at least is, gosh, what a great question. Like, what is the answer to this? I think I'm actually an advisor on a like an NSF, National Science Foundation funded project that's being done by a think tank in partnership with PBS, and they're really concerned about this very question, which is, you know, we see data, we see statistical concepts referenced in media all the time. I mean, COVID being kind of the example that's on all of our minds, but also climate change and all the most kind of pressing issues of our time. And there's so little statistical literacy. And how can journalists kind of play a role in helping to build that in the way that they write stories? And you know, I think having been working with this team for a couple of years now, it's like it's not easy to do. I mean, I think ultimately our education system is going to have to take this more seriously, like at the fundamental curricular level. But I don't know that. I'm not sure what the answer is to this. I mean, but I share your feeling that, you know, we all need to be sort of conversant with. And I'm not a quantitative methodologist by any means, but I, you know, of course, had to take statistics in my sociology PhD program. And I'm so glad I did, because I mean, I can't believe I had to go to a PhD program before having to learn that. So.
And again, I would say what you're doing here at Rutgers is just an example. So when, you know, in industry, what we do is we form journal clubs. And so we meet together, we read papers in these fields. And so you have to carry this effort everywhere you go. So no matter where you are, if you have siblings that are in high school, volunteer to teach to the you know, the kids in high school, give them a session on data science. So I think you have to just carry the momentum that you're doing, this grassroots effort, and continue that everywhere you go.
I agree with what you were saying about the importance of data literacy and getting it to students like as soon as you can at their young years in their high school times. I think it's extremely important. In fact, I have read articles where people are saying that inhibiting or not accepting that data literacy is incredibly important today and needs to be taught to children is almost kind of like withholding knowledge and withholding their opportunities, and is quite criminal, especially in areas and places with lower socioeconomical classes and people struggling to climb that ladder. Speaking of such issues and criminal activities, along with all of the things that we've talked about, all of the great things and efficient things that have arisen with data science, has also come with the rise of all things bad, such as inhibiting knowledge and inhibiting data literacy. For example, cyber threats, data crime, they're extremely relevant topics of discussion right now. So personally, what is the most difficult to stomach data crime that you've ever witnessed? You know, in other words, what's the worst way that you've seen data visualized, whether it was to purposefully mislead others or just simply a bad choice to model information?
Great question again. I mean, I think, you know, when I think of, one of the examples that I think of when I think of like ways that data was poorly communicated to the public, I think of the polling data leading up to the 2016 presidential election. And I really think a lot of journalists kind of fumbled the ball there in terms of conveying, what just basic concepts of probability and margin of error and those sorts of things. And just like in a way that, may have potentially even suppressed turnout. So I think that's one example. In terms of what is hardest for me to stomach and the things that scare me about the growing prevalence of data science and algorithmic decision-making in so many fields, it's not really about the way data is presented. It's more about over and over, it seems we see instances of data science used in a way that purports to be more fair, more objective, less tainted by human biases, but in fact sort of simply reproduces so many social inequities, but does so then with the veneer of being truly objective or just or fair. And so that is something that that deeply concerns me, and that I think that it's one of the things that we're trying to tackle in the data in context class, is to really try to evaluate applications of data science as they play out in the world, including the consequences that they produce for people's lives and whether we think that those are just. So that's something that that I think about a lot.
Yeah, that part of the where does the data come from and what happened to it before you saw it is a really critical aspect. It's not as much fun as looking at a plot and pointing out, what sort of obvious things they did to sort of manipulate things. And I have trouble in teaching that there's a sort of combination of, I'm looking for a data set that illustrates something. I have a very limited amount of time to sort of like really plumb, the data set, how it turned into that form. And if for every data set I spent sort of sufficient time talking about its context, it would be very difficult to cover sort of the technical things I need to cover. But those really are sort of crucial things. And just as an example that's sort of in the news a lot, or sometimes there's this, the federal government maintains this thing called the Vaccine Adverse Event Reporting System. And so basically anybody can put in that there's been they've had a reaction. There was actually a reporter to sort of illustrate a point a number of years ago, put in that this is pre-COVID, had gotten a vaccine and it had turned him into a gorilla. And there's nothing that prevents that from happening. And so you can sort of pull this data. You can say, this is federal government data, and you can find things that are sort of ridiculous. I think there's something like 1 million deaths reported as a consequence of the COVID vaccine, which cannot possibly be true. So if you know about the VAERS, then that's not. It's not meant to sort of establish rates. It's just meant to like pick up subtle things, and that there's a lot of sort of nonsense in the data. But if you don't know that, it looks like it's quite sort of frightening, and people who have particular agendas that they have can sort of use that. And so I happen to know about that one, but I don't know about like some other database that I'm using in class because it's cute or it illustrates the point I want to make about regression or something like that.
All right, so now we can move on to the data science as a job market category. So in a bit of a more recently relevant question in the last few years, I'm sure we're all aware of the pandemic that's been going on. And so a lot of the people in college now are essentially going to be entering a job market that at least now is recently recovering from the pandemic. So specifically in terms of the data science field, our question base is what are the job prospects with this field, and whether the pandemic or events around the pandemic have caused the fields to grow at a faster rate or stop growing or anything along those lines.
I looked up a report from a consulting company that consults about data science jobs, and they referred to 2021 as a boom year in data science. So I'm sort of guessing that's going to continue despite pandemic effects.
And I saw something recently that just having a college degree, there's only a 3% unemployment among students with college applicants with a college degree. So I would imagine it's even smaller with someone with lower with for someone with a degree in a quantitative field. Yeah, and also it's just the wide variety of positions that are opening up. I mean, we keep talking about data science, but the job titles that you see, data engineer, data analyst, when you read the job descriptions, they're really job descriptions that relate to the courses in data science or the techniques of data science. They want individuals with some ability to run machine learning models, do some predictions, and they might even be called a data analyst. But to me, that's a data science position.
Mhm.
So it's hard. So I just think it's wide open. When I just saw, if you know anything about Flatiron Healthcare in New York, I worked with them when I was at Pfizer. I just happened to see something they put out on LinkedIn, and I looked at their jobs, and they had over 100 job openings, and maybe at least 40% to 30% were related to quantitative job titles.
Professor Petre, would you like to add to that?
No, I think that it's sort of been said, like it seems like it's just this sort of burgeoning field that's it seems like a good bet to place your hopes on. And then I think, and this is partly my own place standpoint from about this, but I think that, especially the field, you all need jobs, and then the field really needs people coming into the market who are really thoughtful, right? So, able to apply data science skills, but also to really think critically and ask good questions and, interrogate sources of data and all that stuff. And so that's, so I think it goes both ways. Like, you need the jobs, but they need you. They need Rutgers students.
Yeah, that's a great point. And I think it's a reason why when the undergraduate certificate first came out and then later the minor, so many students jumped on the opportunity, because I think once COVID was beginning and we were, or at least the quarantine was starting to implement, and we were seeing a lot of rapid effects in the economy. And around the same time, a lot of my friends who were graduating and who are now alumni couldn't get jobs with their fresh degrees and everything they had learned, and they were really deeply concerned. And then those of us still at Rutgers heard about the data science degree program, jumped on it, and jumping on anything that could diversify ourselves, make ourselves more unique, make ourselves more interesting, make ourselves more likely to get employed. And in that same way, talking to those alumni who now are in employment, are now have gotten used to being in the job market, they talk a lot about the first kind of recommendations they have or advice that they like to give is about classes and which ones to take and which ones were actually relevant to the work that they're currently doing. So in your opinion, of the data science classes that you know of on campus, which do you think, do you see yourself using those concepts in the work and research that you do every day?
I may be biased, but I think the regression course, I'll let a course in machine learning, whatever department it's from, whether it's from computer science, from Sky, or statistics, a course in machine. These are all techniques that set you apart in your resume, right? And I just make sure that it's very simple. Take a resume from someone who graduates with a degree in computer science, put on that resume a data science minor. Don't you think that that sets that person apart just from the other candidates that have applied for that job? So I just think it's just a almost common sense thing to do, is to get this this I guess degree, whatever you call it, certificate, minor, major, and get it on your resume. And then also have a passion for it. You could have a passion for journalism, but I would say that being a journalist with a minor in data science sets you apart from the other journalists. Being a statistician with a minor in data science puts you, you stand out among the other applicants. To me, it was simple.
I think I'm also going to be biased in this question based on, but I think, being in the School of Communication, but I think, one of the learning goals in the program that I was really happy to see was a focus on data visualization and communication. So, not just can I do this analysis, but then how do I convey what I find, my insights, in a way that is accessible as possible, and is accurate and is thoughtful, and contributes knowledge. So that's one thing that I think is really cool to see in this program. And then, of course, I'm also gonna plug the fact that there's a key part of this program that is really about understanding the way that data science interacts with society, right, for better or worse, and just kind of developing, again, those tools to think critically about this field. And I think that's something that I see many thoughtless applications of data science in the world. Like, we've designed an algorithm that uses facial features or facial expressions to predict whether someone's a criminal. It's like, what? There's just a lot out there right now that is frightening, and that is not well thought out. And so, the notion that this program, I think one of the goals of it is to really approach this thoughtfully and analytically, is so exciting to me.
And I'll add a few nuts and bolts things. And I do want to mention that I learned, I took graduate linear regression with Jack, so I learned it that way. So linear regression is hugely valuable. Whatever form of some kind of machine learning, the course in the statistics department has a name I can never remember. The number is 486. We're actually changing the name, so it makes a little more sense to statistical learning. I think linear algebra turns out to be like a really helpful way to think about things, as well as useful tool. At the course of, even though it's my own course, I think a data wrangling course, there's one statistics, there's one in CS, there's one in Sky. That's just, it's like, very low intellectual level, but hugely valuable, just practical skill. And then, if you can get a like a seminar course in the humanities or sort of related fields where you can actually spend time engaging with people's arguments and presenting your own, those skills are just so useful. And then this is not a course skill, but just taking the time and energy to sort of pursue your sort of curiosity and stuff. When you come across something interesting, go down that rabbit hole, is really useful and fun.
And the other types of courses that you should focus on are those that have projects, where there's a project team, because that's where you build, even during your college career, a track record of being able to work with individuals. And when you go on job interviews, you could always relate your project experience to the interviewers, because the kinds of questions that you get, they're happy. They can see your resume in terms of your technical skills, but what they don't know is are you going to be able to work with this other individuals? Everybody's working on teams. The days of being locked up in your office and producing no longer exist in the industry. You have to work on teams. There's so many, there might be teams of 15, 20 people, and you have to learn to get along. You have to learn, if your suggestion is not taken, what do you do? How do you go back and talk to individuals and make your argument? Those are that's where you start, learning in courses, when you have project teams, when you're asked to produce a project for the class. Presentation skills, all those you are in the courses. But if it's a course is just going to give you homework assignments, and you complete the homework assignment and you don't really interact with your fellow students, I would stay away from those, or put those, as a secondary level. But the primary ones are the ones where you get a chance to talk to your fellow students. You ask them the same questions you're asking us.
Yeah, just a quick mention. We're going on into our final question, so please. I saw that a couple of people have already left. Especially if you have any questions you want to ask the professors. Right after this, we'll go into the Q&A. So to go actually on the opposite spectrum of the previous question, of course, most of the time, half of the skills that you learn and half of the things that you need to apply in your job are the things that you're learning in your job while you're in it, and the things that you're learning while you're still applying to your job. So what skills do you think are very important for Rutgers students to obtain before that they're not able to learn in certain classes? So like outside skills.
You mean skills relevant to data science or just in general?
Both data science and in general would be good.
So again, a very easy answer for me is verbal and written communication skills. Know the technical aspect, but be able to convey it verbally and in written form to others who may not know as much as you do about the topic.
It's another piece is sort of getting a sense of what's going on in the field. It doesn't have to be like at the research level, but like in my case, sort of figuring out a set of interesting people to follow on Twitter, and what they're sort of talking about, and people wondering about how to approach something, or here's an interesting thing you can do in R, or like how do you do this in SQL, or this company has this really cool way of doing this thing. That's a useful thing to sort of know about. What gives you a picture of like what's going on in the field. That's not just like what you learn in your class.
I follow a data science blog. It's Data Science Central. I don't know if you follow that, but again, that's to me, I see what other young individuals are thinking about in terms of the field, what they're producing. And so there are a couple of blogs like that that are worthwhile to follow outside of class.
I think that's all really good advice. I mean, it kind of ties into a theme, I think, which I often tell my students, which is, I teach a class called Digital Media and Society. And And I say to my students, like, I try, I really try to make the classes like ripped from the headlines, right? Because this stuff is changing so quickly. But I say to them, there's stuff that that we're going to talk about that, by the time in a year, that's going to be obsolete, right? Because now Facebook is Meta, and we have like, but what I want to, for you to leave with is that you have frameworks for thinking about, the platform companies. And so then when something else happens with Facebook, you have a way to analyze that. And so, but I think like the advice that the other two folks have given, which is, just develop a habit of reading everything you can read, or, listen to a podcast or something, but just sort of try to swim in the water of this field, even when you're not, when it's not directly in your course material. And you'll just, I think, interesting connections and ideas and points of curiosity will just come to you if you do that. And, you also, I feel like I've had so many, job opportunities and research ideas just come through the randomest pathways. So being open to, coming across something that's a little bit outside your main area is always good.
That brings us to the end of the questions that we have come up with. I think everyone answered very deeply and thoroughly to all of the questions that we covered. I feel like almost like every possible question you can ask about data science. But of course, people may have some more specific questions they want to ask themselves. So anyone who's ready to unmute themselves, please unmute and ask your question.
Also, if you're maybe not comfortable with speaking, you can also put it in the chat and it can be read out loud. Any questions about anything that any of the topics we discussed, or anything else that you're just interested in knowing? While we wait, some people might be typing. While we wait, I had like a little fun question. So you mentioned just having like a passion for data science and just absorbing as much as you can, have it going on blogs and like listening to podcasts and things like that. So I was just curious, what are your kind of favorite data science wormholes to kind of go down? Like, what are you really interested in? Like, I love music, like really passionately, and I love to see how music is becoming more inclusive with like other genres and things like that. And not just that, but also how other countries approach the music industry, and how they use data and analyze data in order to market their artists better. So that's something that I'm personally really interested in. What about you? What is something, just like a little passion that you have?
I was going to say, I'm very interested in, I have no particular expertise in it, but I'm very interested in data visualization. So, when I see something that's interesting, sometimes I'll see if they've got like a GitHub repository that shows how they did it. I sort of collect, books on data visualization, put them under my pillow in hopes that I absorb it, things like that.
Yeah,
go ahead.
I'm sorry. Yeah, just for me, it's really just looking for different ways of teaching material. And so I just I listen to podcasts also. There's this whole crowdsourcing concept, right? And so I enjoy listening to those types of podcasts. And but it's focused on trying to find new ways of teaching material.
I would say one of my obsessions about this is the way that is kind of, it relates to what you said, Michelle, about music and the music industry, but just the way that personalization happens. So the way that a stream of content, whether it's on Spotify or it's on a news site or it's on a social media platform or it's on Netflix, right? The way that they use data and analytics to craft taste profiles and then recommend content based on that. Any article that's about the mechanics of how that works, I will just gobble that up. I can't get enough of it. I find it so bizarre and fascinating, and yeah.
So we can go into the questions that were left in the chat by some people. So one person says that I'm a computer science major. Can you suggest some computer science electives to take that are data science related? I'm guessing they're specifically asking for stuff that will count towards their computer science major, because I know Data 101 is a computer science course, but it does not count towards your major or minor.
The problem is I'm not so sure what counts as a CS elective.
Same, unfortunately, yeah.
Yeah.
Yeah, I think I would just recommend to the person personally, just go onto the computer science like list of courses and look at specifically what courses are count towards your elective, and the ones that count towards the elective, go through them, and they all have a short description, and all of them will tell you if they're more data science related or strictly computer science or more theoretical, like discrete, for example. Yes, somebody has a raised hand up, so please go ahead.
Hi. So I'm not actually like a CS major. I'm actually like a business major, and this is kind of like a field that does interest me. And I just don't have enough time to actually pivot to something like computer science or statistics. So I was just kind of wondering, as somebody who's like a business major, what is kind of something that I could do to just kind of make myself stand out in this field, maybe compared to some of like, somebody who is like a CS major.
We should definitely look at the data science certificate or the minor, and if it's not going to work to actually take all of the courses for it, to look at the courses that are part of those things, and put together something out of that. But that's where I would start.
Also, before we move on to the next person who has their hand up, someone in the chat asked, where are some good places to apply for internships?
Yeah, so my answer to that is basically there are all these sites where they advertise positions, and whenever I've wanted to look at for students what the intern, all I do is type in data scientist plus intern, or statistician plus intern, computer science plus intern, and you'll be surprised how many companies are posting now through these job sites for interns. And I think you need, you just need to Google, summer interns, or and they pop up. And again, the hiring is basically done through the internet, right?
Okay, we can now go to the next person that has their hand up, Carl, I believe.
Yeah, can you guys hear me?
Yep.
Yeah, I was particularly interested in the whole data literacy topic because I wanted to get your opinion on this. How much do you guys think the data illiteracy is due to the fact of uninterest, or is it more so that the data that's being presented to people is not necessarily what they should be seeing? So to elaborate, a lot of news will run stories of things that are not really important. They should be running stories about climate change and things that are more pertinent, but that's not really going to get the clicks, and by extension, it's not going to get them the money. Everything is profit, right? So I guess the question is, do you guys think data illiteracy is more so due to what the people who are in charge of presenting the data are prioritizing, or is it just the general public not having the interest that they should be having?
It's a really interesting question. I mean, I think I don't think that it's the public not having the interest that they should be having. I think that sometimes I think sometimes like people are kind of just math phobic and maybe weren't given the tools in school to overcome that or feel like this was something accessible. And so, you know, when you, I think that it's sometimes hard when you see data presented in the news, it's not, you know, about climate or something like that. It just maybe sometimes doesn't feel like it's like, maybe people don't feel empowered that they can interpret this, that they can have an opinion about this, that they can make sense of this. You know, I think that climate change is kind of a notoriously difficult topic to cover journalistically for some of the reasons that you mentioned. People are very worried about it, and increasingly so as the years go by. But in terms of, you know, how it fits with the way that the news works as a business, it's tricky. But I don't think it's that there's a lack of interest in these issues necessarily. I think that there maybe has been a bit of definitely a lack of data literacy education, and then maybe a little bit of a lack of imagination on the part of the media industry and how to present some of this stuff.
Thank you so much.
Also in the chat, somebody was asking, in the professional field, is a data analyst related position a good starting point to gain expertise necessary to become a data scientist?
Yeah, I'd say yes. I mean, it most likely if you're applying for a job with a bachelor's degree, you know, your job title is probably going to be something like that. And it can be a little disappointing. I've had students tell me that, you know, they learned all this advanced modeling and the first 3 months involved Excel spreadsheets. But I've also, you know, I had a student who said that, you know, her boss pulled her aside in the first week and said, so I need you to learn a little bit about Bayesian statistics. And she said, oh, I had a course in it. And so all of a sudden, you know, she could do, you know, a bunch of stuff like right off the bat. But so a lot of, when I did admissions for our master's in data science, a lot of the students had these kind of you know, data analyst jobs for, you know, they graduated from college, they'd done that for a while, they decided they really liked that area, and then they realized they decided to advance their field, their career, they wanted to get a master's. But so I think that's a not at all uncommon career path.
And I hope students realize that in large companies, basically your first job is not what you wind up doing after a couple of years. There, in large companies, basically there are postings. You know, as soon as you get there, you'll start recognizing there are postings for jobs, and companies, most companies, will rather hire within. So what you start out doing the first year, I guarantee 2 or 3 years later, you're in another position that is more in line of what you expect to do, and you have more passion for it. The first job is really getting your foot in the door, learning what it means to go to work every day, whether you're working from home or not. But it's you know, just getting used to the whole industry. But very soon you'll start looking at postings, you'll network, there'll be a person who they'll mentor you, and because that's part of what people do and get excited about. So I would say the first job is really doesn't have to be the job that you know that you see yourself doing 10 years from when you start in the company, especially at the larger companies.
To the next question in the chat, a person is asking, are there any recommendations for a graduate school of choice in data science? Which schools offer a graduate degree in data science?
Rutgers.
Right. So it's an easy answer for the which schools, which is virtually every single one. And you know, none of the programs are more than none of them are more than 10 years old, and very few are more than 5 years old. I think NYU was the first one about 10 years now. And what will happen is every program has different emphasis. Some are run out of CS departments, some statistics, some out of an engineering school, some out of a business school. Some will be sort of more theory, some will be very practical, some will be 1 year, some will be a year and a half, some 2. So there's just a lot of like what matches up best to you, rather than like this is the best one across the board.
Okay. Thank you. We went over the time limit over like almost 15 minutes. So thank you very much for our professors for staying on for a little longer. We have 2 more questions in the chat. We'll just cap it at that and then we'll let you go. Thank you again. One question, the first question, oh, sorry, I was reading the wrong one. Should someone have a strong hold on statistics to get into the data science field?
So I'm sorry to be talking the whole time, but I'll take this one too. I think so. You may have seen that there's a Venn diagram about data science, and it's like statistics, and I think the original said programming or computer science, and then there's sort of domain, and data science is supposed to be the intersection of the 3. So I think that's turns out to be a somewhat misleading Venn diagram, because in some sense data science is everything that's in any of those circles. And a particular person might be anywhere in there or move around. So, if you're strong in statistics, then there's a certain way you can be a data scientist. But if you're strong in other aspects, then there are different ways to be a data scientist. And there are plenty of people who this goes to something that I think both of the co-panelists said earlier on, is that you can have a job where you know data scientists, but your job title is maybe something entirely different. But the fact that you understand stuff about data science means that you can work with other people and you can use things. You don't have to have been a straight A student in all your statistics courses to do that.
It's also just organizational structure. Again, the information technology group may just be hiring individuals called data scientists because the statistics group has the responsibility for hiring statisticians. But when you look at the job descriptions, they're basically almost the same talents, and they just work on different projects. Maybe the data science or more scientists are oriented more towards market outgoing, outfacing projects. Statisticians may wind up more in clinical trials. But again, it's really the same set of skills. Mm-hmm. Titles may differ slightly.
Got it. Thank you. And then our final question for the night. What are some differences in the day-to-day work of a statistician versus a data scientist?
So when I was on a project team, when I'm on project teams with data scientists, it seems that the data science group had better access to high-speed computers and the newest technology. So they somehow were given the responsibility of generating the output and developing the models, the machine learning models, and the statisticians were there more to be a guide on the statistical aspects. So it also depends on what company you're working at.
Yeah, I think the previous answer and the answers to the previous question kind of overlapped with this one, so it was already pretty much answered. Once again, thank you so much for everyone for coming in, especially the professors. If you would be comfortable, could we post your emails in our Discord and then in our group me, so if people had extra questions, they could
Sure,
refer to you? Thank you so much.
sure.
Yes, of course.
We'll make sure to do that. Once again, thank you so much for coming. Thank you so much for answering all the questions. And of course, thank you so much for staying over time. We're almost like 20 minutes over. We hope that didn't bother you too much.
No problem.
Thank you for the
And
invitation.
yes, thank you. I hope it helped.
Thank you.
Yeah, if it helps with your career choices, that's a big win.
Thank you. It was fun.
Thanks all.
Thank you. Yeah, I think
Thank you for coming.
Thank you so much for joining us.
Okay.
Good night,
Bye-bye.
everyone.
good night.
Good night.
That was stressful.
Oh, bro. Oh, wait, I need to stop.
It's fine. It's the professors are gone, so whatever.
I need to stop recording. I don't remember.
Oh, well.
Hold on. More.